Hello, welcome back. Let's have the tutorial basically on permutation. We did mention that permutation is not that difficult. This is just about arrangement of different objects. If you have different objects to arrange, how you arrange them is what we call permutation. By recall, we can say that if I have n different objects that I want to arrange, and I want to arrange them in n different ways, meaning 5 objects to arrange in 5 ways. We have each permutation. But in this case, I want to arrange only what? N. So it means that I have n different objects picking R at a time. So let's say R at a time. This means n permutation R. And how do we expand this n permutation R? We have it as n factorial over n minus R1 all factorial. Remember the beginning episode, we mentioned that if I have n factorial, it is just non-zero or non-negative numbers that are less than that integer. So meaning n times n minus 1. You subtract 1 from this number, then we have n minus 2 in that order. So I can still introduce a factorial. So that in this factorial, I have a subtraction continuous. So this is what we have as a permutation. How we can arrange a different object, picking some at a time. So if, for example, I have how many different ways can you arrange 5 books on a shelf? So in this case, we are having 5 different books. How many books are we going to arrange? There are 5. So it means that the R that we are picking at a time is going to be 5. So it means 5 books arranging all 5 at a time. That simply means that 5 permutation what? 5. And 5 permutation 5 is going to be 5 factorial on 5 minus 5 all factorial, which become 5 factorial. 5 minus 5 is what? 0 factorial. And from the factorial, a 0 factorial is 1. 1 factorial is also what? 1. So in this case, this is just what? A direct factorial, which I will just say 5 permutation 5 become 5 times 4, 3, 2, 1. And this divided by 1, since 0 permutation is 0 factorial is going to be what? 1. So what do we get from here? This is going to be 20, 60. So we have 120. We have 120 ways. We have 120 different ways by which we can arrange 5 books on a shelf, whereby we are picking all the 5. So first, second, third, fourth, we change their position. Since there is no restriction, we can be able to get 120 ways to arrange that book. Now, let's pick another example. Look at this. In how many different ways can the letters of the word camel be arranged? Here also, no restriction. So how are we going to arrange it? We are having 1, 2, 3, 4, 5. 5 different letters which we are going to arrange each of the times to be 5, 5, 5. So it could be C-L-A-M-E or E-M-A-C-L. 5 of them. So this simply means that I am having 5 different letters to pick. That is 5 permutation. How many am I picking at a time? I am picking 5. Remember, if we are having this and this simply means they are having what? 5 factorial. But let's see. 5 factorial divided by 5 minus 5 all factorial to give us 5 factorial on what? 0 factorial. What can I do? In this range, as we'll be having 5 permutation 5 equals to 5 times 4, 3, 2, 1. All divided by 1 in the case of this. So this is going to be also 20, 60. So I have what? 120 ways again to be able to arrange the letters of the word camel. It could be in any faction, but we are picking all the 5. This is just arrangement with no restriction. Just look at this. If you have 6 different math books, but you only have 4 different spots on a shelf, in how many ways can you arrange these books? So we are having 6 different books, but the spot we are having is just what? 4 spots. How are we going to arrange it? So that we are taking 4 out of 6 objects. Arranging what? 4 out of 6 objects. If you check our first episode, we can also use the fundamental principles of counting to get that answer. Meaning, the first slot, there will be 6 possible chances to get. The second slot, there will be only left with 5 possible chances, 4 and 3 in that order. But what can we do in terms of permutation? What are we saying? We are saying that 6 to pick from, 6 permutation what? 4. I have 6 different objects to pick, but I am picking 4 at a time, meaning 6 factorial divided by 6 minus 4 all factorial, giving me 6 factorial on what? 2 factorial. I guess that is clear? Because 6 minus 4 is 2. So what do we do in this case? That becomes 6 permutation 4 equals to 6 times 4, I think 5, 4, 3, 2 factorial, then 2 factorial. I can expand both, but I'm seeing 2 factorial, 2 factorial, so it could easily cancel out. So if this cancel out, I should be having 6, 5, 4, 3, all multiplied, because we are multiplying in terms of what? Fundamental principle of counting 1 and our product. So this is going to be 30 times 12, and this is going to be 360. So we have 360 ways of arranging these books, which are 6, but we are picking 4 at a time. You'll be having 360 ways of doing that. Let's look at this one. How many different 3-letter or 3-digit numbers can you form with digits that are 4, 5, 6, 7, and 8? So simply put, we want to pick from 1, 2, 3, 4, 5. We are picking from 5 different letters. How many at a time? 3 at a time. So if 3 at a time, the first slot is going to be 1, 2, 3, 4, 5. Any of them. That's 5 options to pick from. The second slot is going to be left with 4. The third will be left with 3. But let's see how we can do it. So in this case, I should be having 5 options. That's 5 permutation, picking 3 at a time. That means 5 factorial, 5 minus 3, all factorial, giving rise to 5 factorial over 2 factorial. So this becomes 5 times 4, 3, 2 factorial divided by 2 factorial. We know factorial will cancel factorial, so I'll be left with 20 times 3, that will be 60 ways. These are the ways by which we can do it. Now, looking at all these examples that we have looked at, I think 5 different examples, you can see that permutation is all talking about arrangement of objects, different objects, whereby we are picking a particular one at a time with no restriction. If there's no restriction given, all that we are doing will surface. Now, there are some instances whereby there will be a restriction given to you. In the case of this, we said no repetition. Or if you were told there is a repetition, how are we going to deal with that? That will be in the subsequent episode. So watch this video, share it, subscribe to the channel, leave a comment, constructive comment for us to get interactive, and come back for the next episode of different aspects of that.